Okay, guys, I hope everybody enjoyed their break, but we are going to continue on with our circle unit. We are on page 6 in our note packets. We are in the middle of the page with the heading Day 3 Notes, Arc Length and Sector Area. So a quick review of the words that we will be using. Sector of a circle is a section of the area of a circle. And the arc length is a section of the circumference of the circle. Okay. Sorry, I try and fit that in. There we go. So our area is going to need to have an answer in some unit of measure squared, and our arc length is just going to be in a unit of measure. Okay, so I just kind of want to keep those in mind as we go through these. All right, so let's take a look at our equation. The area of a sector is m divided by 360, where m is going to be that central angle, and that central angle opens up to an arc measure of the same degree. That is the m that we are going to be using, times pi radius squared. Okay? So we are looking at the percentage of the circle this piece is. That's the 30 divided by 360. And then we're multiplying it by the area of the circle. So that looks like this. So area of the sector equals 30 divided by 360 times pi radius, which I'm given as 4, squared. Okay, 4 squared. So I'm going to put that in my calculator and get 30 divided by 360 times 4 squared, which is 16. And I get 1.33. Now you might see that I have not multiplied pi out, 3.14. I haven't done anything there because I want to leave it in terms of pi, right? So my final answer is going to be 1.33 pi units squared because it is area, and I didn't multiply out pi. So if somebody really wants to know the exact area of this piece, they can get their own calculator and multiply 1.33 times pi. But I don't really feel the need to do that because I am leaving it in terms of pi. In terms of pi, pi, or our 2 columns with the squiggle hat is pi. So how does that work with arc length? Well, it works very similarly, but we are still looking at the crust because it's part of the circumference. Central angle opens up to an arc measure that is the same, so 30 degrees and 30 degrees. And now I want to know what percentage is this 30-degree piece of the entire circle. So I'm going to set it up as a percentage. The length of the arc equals 30 degrees out of 360 degrees total times 2 times pi times radius, which here I'm given as 4. And I'm going to put that in my calculator, and I am not going to multiply out pi. So I'm going to take the fraction times 2 times 4 and put that in my calculator. 30 divided by 360 times 2 times 4. And I get 0.666 repeating. So 0.667 pi, again, in terms of pi, and that is the, and then unit of measure, or unit. make that a little better. So let's take a look at a couple of examples. Example number 1 says to find the area of sector ACB. So from A to C to B, I want to know how much of that circle that wedge is. All right. Well, I'm going to have to figure out that central angle. So the first thing I'm going to do is take 180 and subtract 115 from it to give me that angle measure. So 180 minus 115, 65. So that is 65 degrees. That is the portion of the circle that this wedge carries out. So the area equals 65 degrees out of 360 total times my area, pi radius. My radius is given to me as 6 squared. So I'm just going to put all of that into my calculator, but I'm not going to multiply out pi. So 65 divided by 360 times 36, or 6 squared, gives me 6.5 pi, because I haven't multiplied that out, but it's area. I don't have a unit of measure, but my unit of measure will be squared. So 6.5 pi, or 6.5 pi, units squared. In our next one, we are to find the length of DC. From D to C, what is this crust piece? Well, I know that from D to C, I'm told that's 90, so I don't have to figure that out. So I am going to do the length of the arc equals 90 degrees divided by 360 total times the circumference of 2 pi radius, and our radius is 10. Now I'm just going to put all of that in my calculator except for pi. I'm going to get an answer in terms of pi. So I'm going to do 90 divided by 360 times 2 times 10 and get a final answer of 5, and that is 5 pi, because I have not multiplied pi out, excuse me, in some number of units, inches, feet, whatever. Okay. So remember, if we're looking for area, you want the percentage of the circle times the whole area. If you want arc length, it is the percentage of the crust times the circumference. Okay. So let's flip the page and see what is next. Oh, equations of circles. All right, we're going to do a short introduction on this. Our circles are going to have a radius. They are also going to have a center point. That center point is an XY value, like a coordinate plane, but we've named it specially for circles as HK. And that's really just an XY coordinate on a grid. Radius is still from the center point to the circle line. That is a radius or a distant measure. So HK represents the center of the circle, and R represents the radius of the circle. And we have this special equation that I need you to pay very close attention to the fact that this is a minus sign and a minus sign, and that each of these is squared. Okay? Very important parts of this circle equation. Okay? So what we have is x minus h, which is our x value of our center point, y minus k, or the y value of our center point, equals radius squared. Okay? Now then, the special thing about these negative numbers is that if x and y are positive numbers, then you are going to have x minus your x coordinate and y minus your y coordinate. But if either of these coordinates are negative, that's going to make this positive. Okay? Let me show you what I mean. All right? In example number 1, we have a center at +3, -4 with the radius of 9. I'm going to write out the format of the equation, and then let's fill it in. Okay, so x minus h, all of that squared, plus y minus k, all of that squared, equals my radius squared. My x value for the center point is +3. X minus +3, all of that squared, plus, here comes the doozy, y minus -4. All of that squared equals radius squared, or 9 squared. Okay? What does that turn into? X minus 3. I don't have any simplification, so I'm just going to write it down. All of it squared plus y, but I've got a negative negative. That makes this a +4 in my equation. All of it squared equals 9 squared. 9 times 9 is 81. This is my final equation for that circle. Well, what if I've got a 0? Okay. The process doesn't change. I'm going to take x minus h, all of that squared, plus y minus k, all of that squared, equals radius squared, and let's go through and fill in. My x coordinate is 0, so x minus 0 is just x. It is still squared. Plus y minus a +5, all of that squared, equals radius of 5. 5 squared is 25. That is going to be my final answer for the equation of that circle. Last one. Our center is 0.5, -0.5, and our radius is the square root of 8. This is interesting, okay? I'm not going to change my process. X minus h squared plus y minus k squared equals radius squared. X minus +0.5, okay. Just going to fill it in, plus y plus or minus a negative number, all of that squared, equals the square root of 8 squared, which is just 8. Okay? That is going to be my final answer for the equation of the circle in number 3. Now we can pull information out of an equation. Same thing, x minus h. H is going to be +3. Oh, I've got that pesky plus. That means my y coordinate had to be negative. That is my center. And my radius is the square root of 144, which is 12. So I've got a center of 3, -2, and a radius of 12 units, inches, feet, whatever. Okay. Looking at the next example, we again have x minus 3.5. So 3.5 had to be positive. And then this had to be negative coming in, because I had multiplied it by a negative. That is my center. And my radius equals the square root of 12. And 12 breaks down into 3 times 4. And 4 breaks down into 2 times 2. Under radical rules, pairs get out of the doghouse. So my final answer for the radius is 2 times the square root of 3. That is the center and the radius from this equation. Okay. Now I'm supposed to write an equation of the circle shown on the grid below. All right, so let's see. This is -1, and this is -1, 2, 3. So my center is -1, -3 on the grid. I'm going to write that down. And from the center to the edge of the circle is my radius. 1, 2, 3, 4. Radius equals 4. Now I have all the pieces I need to plug it back into that original equation. X minus h, all of that squared, plus y minus k, all of that squared, equals the radius squared. Let's just fill it in. X minus -1 turns into x plus 1, all of that squared, plus y minus k, or minus a -3, that turns into plus 3, all of that squared, equals radius squared, 4 squared, which is 16, and that is going to be my final answer for the equation of the circle in the grid. Okay, I'm done.